right, I'm here with SanfordFlipMath. This is Miss Benson speaking this time, and we're talking about finding inverse functions. We're working with the Springboard book, so this is in lesson 6.1. So we're doing just a little bit of a review on what we've talked about in class. So first of all, we're going to talk about the difference between a function and an inverse function. So we have our function of f of x, and our inverse function, we're going to write it as, I'm just going to write it as FNC for right now, but inverse function is f, and it looks like it's to the -1 power of x. That's not what it means, so just right now get it out of your head. This is not what this means. It doesn't mean 1 over f, so we're just going to try and ignore that right away. This is just how we're writing an inverse function. A big thing to remember about our inverse functions is that the domain of f of x equals the range of the inverse of f of x and the range of f of x equals the domain of our inverse of f of x. Okay, so here we're talking about splitting or switching x's and y's, switching what we're putting into our function is becoming what's coming out of our function. So when we're talking about finding the inverse of f of x, we're going to go back here and add a page instead. We need to know a few rules when we're working with our equations. So we know we're switching our domain so that it becomes our range, and our range so it becomes our domain. So in order to do that, we're switching our x's and y's, but we're going to just write out some rules so that we can just follow these step by step as we're working with our equations so that we have a basic map to follow. Okay? So these are going to be our 4 basic rules for this. So the first one is to rewrite y for f of x. And this is just to help ward off any type of confusion. It helps to remember that since domain is x and range is y, and that's what we've been learning, that you're switching your y's and your x's versus having to switch other things around. Okay, so the next thing that we're going to do is, as I've been saying a few times, switch our x and y. So we're going to put x's where y's were and y's where x's were. So whatever it was beforehand, that's what we're just going to flip-flop it. It's different places. And we'll see some examples of this on the next couple of slides. Our third step is to solve for y. So once we get it switched around, you're going to solve for y. So it looks like it did before as a y equals, but the equation's going to look different. So the only thing that's going to look the same is the format. So it's not going to be x equals anymore. You're going to switch it so it's a y equals, since a lot of our equations often look like y equals. So, and then our last step, so that we know we've changed it from a function to the inverse of a function, we're going to write it as that funky notation f inverse of x, or the inverse of f of x, or there's several ways to think about it, but whatever as long as you're thinking inverse in there, that's the main thing. All right, so we're going to follow these steps, and now that we've talked through them, we're going to work on the next page with a couple examples. So we'll start with this one here. So we have our rule number 1. Our equation is f of x equals 4x minus 3. So what we want to do first off is write y equals our 4 times x minus 3. Okay, all we did was change the f of x to y. That's our first step. So step number 2 is switch our x's and y's. Now, just so you know, I'm going to leave these as, I'm going to switch the colors so that your x is now green and your y is now going to be blue, so that you can see with color as well as with location and where it is in the problem that we're switching our x's and y's. Okay, so the next step is to solve for y. So here we're just, now it's algebra. So it's just like you always want to get it, a lot of times you want to be at that y equals because that's what's comfortable. That's exactly what we're doing here. So we're going to add 3 to both sides to get x plus 3 over here equals 4y. I wanted to make my x green here and my y blue. I'll stick to that color. And then the next thing we're going to do is divide both sides by 4. That will get our y by itself. So we have x plus 3 over 4 equals our y, which again, I keep forgetting to change the color here on you guys. But there we have our y by ourselves. Now again, we kind of talked a little bit in class today, sorry that just extended the page a bit, about another way to write this. So just for those of you who are wondering, we can also write this as x over 4 plus 3/4 equals y. Now, don't get hung up on that, but just so you know, there's a couple different ways to write this. Now, our last step that we wanted to touch on is making sure that we know that this is the inverse. So I'm going to leave the f inverse blue so you can see that it's the same as this y, and write that as f inverse of x, or the inverse of f of x, is equal to x plus 3 over 4. And we've successfully found the inverse of f of x. Now this is different, so you can see that this y is different from our first y. I indicated that with the colors, and also just the equation is different. We did the opposite operations on our variables in order to get this. Okay, so we're going to do one more example and walk through the steps. So this time we're finding the inverse, where our f of x is equal to negative 3/4 x plus 5. So our first step, we're just rewriting our x's and y's. So our y, or rewriting it with y equals instead of f of x. So negative 3/4 times x plus 5. All right, now we're doing our switcheroo here. We're switching our x and y. So again, this is going back to what we looked at the very beginning. The inverse is when you switch the domain and range. So in our new function, in our inverse function, we're going to get it so that our domain is equal to the range of our original function, and for the inverse, the range is equal. Let me just say that again for you guys. I know I'm misspeaking here. So the range of the f of x is equal to the domain of our inverse of f of x, and vice versa for the domain, or the range as well. Okay, so that's again why we're switching our x's and y's here. All right, so now our next step is solving for y. We're going to then subtract 5 from both sides in order to get x minus 5 equals our negative 3/4 times y. Now this is, I know it's a scary fraction here. We're going to multiply both sides by the reciprocal. Now don't forget that negative there in front. We also need to multiply by that. So here we're multiplying both sides by negative 4/3, because that will undo both the negative on this side, and if we multiply these two together, our numerator and denominators cancel out for both our 3 and our 4. So That's how we can get our y by itself. So we get y is equal to -4/3. We're going to have, whoops, don't want to make a plus sign there, or bring up the keyboard. X minus 5. And this is technically okay to leave it since we left y by itself, but just so that we can see what happens, I'm going to extend that page there, so don't freak out. We can see what happens when we distribute that -4/3. We're going to have our y is equal to a -4/3 times x, and then also a -4/3 times -5. So then we have our, I'm going to just add -5 times -4/3. Two negatives make a positive. So our final answer is going to be -4/3 x plus 20/3, 20/3. Okay, and our final piece, the final step that we need to do still, if we look back up to our rules here for finding the inverse, is to write it as f inverse, just so that we know that that's what we found is the inverse of our f of x. So we're going to write that as the f inverse, or the inverse of f of x, is equal to -4/3 x plus 20/3. All right, so just to recap, we went through what an inverse means. It means that we're switching our domain and range. It means that we're also switching our x's and y's. So we went through the rules for rewriting a function as its inverse. And thanks for watching. Hope this helps. See you in class. Bye.